All right, we're going to get into some sequences and series. A sequence is essentially just a list of numbers that has some sort of pattern to it. The definition is a function whose domain is the set of natural numbers. So you've got some sort of equation that represents whatever that pattern is. There's two ways that we can write a sequence. The first way is what we call an explicit rule. This is like your actual formula or an actual function. We use this notation of a sub n to represent a sequence. N represents what term in the sequence you're looking at. So if you're looking at the first term in the sequence, n would be 1. So we could write that as a sub 1. So a sub 1 would represent your first term. And with an explicit rule like this, 5n plus 2, your first term, a sub 1, is the number you would get if you took 5 times 1 plus 2. So your first term is 7. A sub 2 would then be your second term. So when n is 2, 5 times 2 is 10 plus 2 is 12. The nice thing about an explicit rule is that at any moment you can find any term in the sequence. If you wanted to find the 100th term, you take 5 times 100, which is 500, plus 2. The 100th term is 502. And so with an explicit rule, you can find any term in the sequence. The other way we could be given a rule is what we call a recursive rule. And a recursive rule is a rule where you start by being given the first term. So you can see here we're given the first term, a sub 1 equals 3. So we start out with that. Okay. And then instead of giving a formula to how we can find a certain term in the sequence, what we're given is a rule about how we find the next term. So you'll see this notation over here where we have a sub n plus 1 equals 2a sub n. So a sub n represents some term in the sequence. And what this says is when you take some term in the sequence and times it by 2, that would give you the term a sub n plus 1. Now a sub n plus 1 would be the term right after a sub n. So what this right here is telling you is if you take a term, times it by 2, that'll tell you what the next term is. So that's why in a recursive rule, you have to be given the first term because you have to know where to start. So we're told that the first term is 3, and then to get to the next term, you times the previous term by 2. So if the first term is 3, the second term would be 3 times 2, which is 6. The third term would be 6 times 2, which is 12, so on and so forth. All right, so we're going to look at backtrack for a second, sorry. The downside of a recursive rule is that unlike with the explicit rule where I wanted to find the 100th term, so I just found the 100th term, in a recursive rule, if you want to find the 100th term, you have to find all 99 terms before it, before you can get to the 100th term. So one thing we will look at is, in some cases, how we can try and rewrite that recursive rule to make an explicit rule. So that's one thing that we'll be doing. And first we're just going to look at a couple of types of each of those. So here we have an explicit rule. You can recognize an explicit rule because you're told a sub n equals, and then you've got an equation that just has n's in it. So to find the first term in this sequence, we're asked to find the first 6 terms. We need to plug in 1 into the sequence. So to find a sub 1, I'm going to take 1 times 1 minus 1, which is 0, times 1 minus 2, which is negative 1, all over 6, which gives me 0. So the first term in this sequence is 0. A sub 2 Now I'm going to plug in 2, so that's 2 times 2 minus 1, which is 1, times 2 minus 2, which is 0, all over 6, which is 0. So the second term is also 0. A sub 3 would be 3 times 3 minus 1, which is 2, times 3 minus 2, which is 1, all over 6. So 3 times 2 times 1 is 6, divided by 6 is 1, so the third term is 1. A sub 4 is 4 times 3 times 2, all over 6. 4 times 3 is 12. 12 times 2 is 24. And 24 divided by 6 is 4. A sub 5 would be 5 times 4 times 3, all over 6. 5 times 4 is 20. 20 times 3 is 60. 60 divided by 6 is 10. Alright, now the sixth term, it's not the last one, but the last one we're looking for, so that's 6 times 5 times 4. 6 times 5 is 30. 30 times 4 is 120, and 120 divided by 6 is 20. So those are the first 6 terms of this sequence. Alright, here we're writing the first 6 terms of the sequence, and then we're writing an explicit rule for this sequence. And this is actually that first one that we were looking at, this recursive rule. So we already talked about how to kind of get this one. We're told that the first term is 3. Now, we are asked to write an explicit rule on this one. So as I'm doing this, as I'm writing out the terms, I'm going to just write down how I got those numbers. That's going to help us figure out the pattern, which would then in turn help us find that explicit rule. Okay, so we start with the 3. And then 3 times 2 is 6. So I'm just going to kind of put a little arrow here and say that we got that by taking 3 times 2. Okay, then the next term we times by 2 again, which is going to give you 12. So that's the same thing as saying 3 times 2, which is that previous term, and timesing by 2 again. Then 12 times 2 is 24. So that's that previous term, which was 3 times 2 times 2, and times by 2 again. And then 48, which is 3 times 2 times 2 times 2. That's the previous term, and then we have an extra times by 2. And then last, 96, which is 3 times 2 times 2 times 2 times 2. 1, 2, 3, 4. So that's the previous term times 2 again. Okay, so again, for this first part, the writing the 6 terms of the sequence, you just had to write the 6 terms of the sequence. But when we're trying to find an explicit rule, one thing that can help you do that is to write out these right here. So those are basically how you got each of those numbers. Okay, so we can hopefully see a pattern here, and that's why we took the time to write those out to help us find the pattern, because that pattern is what we need to write the explicit rule. So what we see is, we see the first one is 3. So this one was just 3. I'm going to go ahead and write in that one. And then it's just taking that and timesing by 2 a bunch of times. So you can see this time it was just timesing by 2 once to the first power. This is 3 times 2 to the second power. 3 times 2 to the third power. 3 times 2 to the fourth. 3 times 2 to the fifth. And hopefully you're seeing this pattern. So then to try and come up with the explicit rule, we need to try and ask ourselves, how would we find, for example, the 100th term? when we're looking at this pattern, the first term was just 3, the second term was 3 times 2 to the first power, then it was 3 times 2 to the second. The 100th term, and you can pick any term, I'm just using 100 as an example. So the 100th term, hopefully if you can recognize this pattern, would be, obviously there's going to be a 3, we can see every single one of our terms has 3, and then it's going to be times by 2 a certain amount of times. And if you look at it, with the 6th term it was 5 times, with the 5th term it was 4, with the 4th term it was 3, the 3rd term it was 2, the 2nd term it was 1, and the 3rd term it was actually no 2, so that would be like to the 0 power. So it was always 1 fewer timesing by 2 than what term you were looking for. So if we're looking for the 100th term, it's going to be 99. So we can start to see this pattern, and that can help us formulate this explicit rule. Okay, so our overall goal is to get that explicit rule which says a sub n, that again, that n is going to represent which term in the sequence we're looking for. So we can see our pattern, there's always a 3, and then it's going to be timesing by 2 a certain number of times. And since we recognize the pattern was 1 fewer times than which term I was looking for, if I'm looking for term n, my exponent is going to be n minus 1.